Okay, perfect. All right, let's have a look at another question, then I'll let you loose on some of these. Could you have a look at question... Okay, let's have a look at question 5m, where you've got 4 to the power of a half times x plus 3 minus 5 to the power of 1 minus 2x equals 0. Okay, so that's going to be question 5m if you're following along on the screen. Okay. Now this is a little bit different, isn't it? It's different to what we've looked at before. So what are we going to do here? Can you give me any suggestions? Okay, I like your idea. I like what you're thinking there. So you're trying to make that into, you're trying to isolate that power and trying to isolate that power on itself by taking logarithms, okay? I think the issue is look, we've got different bases going on, haven't we? And we're combining them together with subtract. What I would personally do in this case is to isolate them using the equals. So in other words, I take that negative 5 to the power of 1 minus 2x on that right-hand side. Okay, so let me show you what I mean. If we take this on the right-hand side, I'm left with 4 to the power of a half x plus 3 is equal to 5 to the power of 1 minus 2x. Okay? So I've just simply taken that term on the right-hand side. The reason why I do this, you're right, you should be sensing logarithms going on here because the thing which we're after, the x, is in the power. Okay, so if the thing which you're after is in the power, as a general rule of thumb, always use a logarithm. Okay?
We multiply like 4 with 5 and the 5 with 4.
No, we don't. So we can't multiply the 4 with the 5. No, no, we can't do that. But that's a good idea. Yeah. Okay. Okay. So you're making that the base and that the power. You could do. You could. The simplest way of dealing with this, and I think what you're saying there is actually a slight variation on what we're going to do. Okay. If I take this and if I apply a function to both sides, okay? So for example, if I have 5 equals square root of 25, for example, I could apply a function, whatever function I like, as long as it's to both sides. So as an example, I could square both sides. That's totally allowed. Okay, that function there is squaring. Okay, or I might want to take 5 equals root 25, and I might want to add a function such as plusing 5. Okay, that would also be allowed. Okay, now the function I'm going to use here, because the thing which I want is in the power, is a logarithm. Okay, so I'm going to take the logarithm of both sides. So I'm going to take this 4 to the power of a half x plus 3, and I'm going to take the logarithm of it. Okay. Now in this case, I don't care what the logarithm is, so I don't care what the base of the logarithm is, so I'm just going to write log. Okay. Now on the right-hand side, this 5 to the power of 1 minus 2x, because I've taken the logarithm of this side, I'm also going to take the logarithm of the right-hand side as well, like so. Does that make sense? So you're happy I haven't really changed the equation as such. There's still the equality which is preserved. It's just I've just taken a function of both sides, much the way I was doing over here. Does that make sense? Yeah? Now, can you think of laws of logarithms? Because I've still got the issue that the thing which I'm after is in the power. So can you think about your laws of logarithms so that the x, the sort of expression up here, is no longer in the power? Okay, so just think about your laws of logarithms. Is there a way of getting rid of these powers in the logarithm? So just remind me of your laws of logs. Okay, number 1, can you give me a law of log? Law of logarithms. Good, okay, so perfect. I think you're thinking about laws of indices. Okay, laws of logarithms. So you have log of a plus log of b. What does that be equal to? Perfect. Okay, and then number 2. Can you give me another log? Perfect. So if I have log of a minus log of b, that should be equal to log of a divide b. Good. Any others? What about if I have something like this? Log of a to the power of b.
6 log b.
Okay, good. That's a b, but that's fine. So b log of a. Good, well done. Okay. Now I think that's the one which we want here, isn't it? This one here.
Oh yeah, we'll take the powers and put them in the
Perfect, well done. Yep. So the reason why I took logarithms of both sides is because I can do that. Like if I'm sitting here, I'm like, what can I do here? Clearly, if I had the same base, I could just make those two things equal to each other. We looked at examples like that. But in this case, they're not the same. That's fine. Logarithm still works. So okay, if we bring this power down, I end up with a half times x plus 3. Make sure you put it on a bracket, because obviously that's the whole power. Times by log of 4. And that should be equal to, well, okay, again, I'm going to bring this power down. So it's going to be 1 minus 2x times by, well, log of 5. Okay. Okay. Right. So what can we do with this then? Bearing in mind we want x. Just remember, log of 4, log of 5, they're just numbers. Okay? Don't need to worry about the fact they're logarithms. These just come out as numbers. Stick them on a calculator like numbers. Okay?
we put the logs together and the x's together.
I agree with that. I agree with that. Okay. What I would actually start off by doing though is breaking down these brackets. Expand the brackets out. Okay. So in other words, I get half x times log of 4 on the left hand side. So this half multiplies with the log of 4, and this 3 multiplies with the log of 4. Do you see that? So get rid of the brackets, make it look a little bit neater, so I can isolate things. So I get half x log of 4 plus 3 log of 4. Can you tell me what I get on the right hand side if I expand this second bracket out?
Log of 5
Mm-hmm.
minus
Mm-hmm.
2x log 5.
Perfect, well done. So now I would do what you advised. In other words, get all the terms with an x in. In other words, this term and this term on the same side, and get the other two terms, the ones with this one and this one, on the other side of the equals. Get out of the way. Okay? So in other words, I get half x log of 4. If I take this on this side, it becomes a positive. So 2x log 5. And then on the other side, so in other words, this is equal to log of 5 take away my 3 log 4. Okay? Okay, so you're looking at this and going, okay, still looks quite messy, right? Well look, it's not that bad, because this thing here is just a number that you can stick in your calculator. It's just numbers, there's no variables involved, I can just stick that in my calculator. So really I just need to focus on this side here. Now what am I after? What do I want?
Multiply.
I want the x, don't I? I want that x and that x. So at the moment the x is distributed over 2 terms. But that's okay, because everything else in that term, the half, the log and the 4, and everything else in this term, the 2 and the log of 5, are just constants, okay? So if I want to find the x, all I have to do is factorise. So if I factorise x out of the left-hand side, if I factorise an x out of here, what am I going to be left with?
Half
Yeah?
log 4
Perfect.
plus 2 log 5.
Perfect. And the right-hand side still stays the same. And now I've got what I want, because I've got x on its own, and x is just being multiplied, okay, albeit it's a really big long bracket, but these are all numbers, okay? So this is just basically an entire number. All of that is just a number. So if I just want x on its own, are you happy I've just got to divide by that? Do you see? So if I want x on its own, I'm going to take the right-hand side, which is log of 5 minus 3 log of 4, and divide by this bracket. So half log of 4 plus 2 log of 5. Now, even though that looks big and horrible and awful, it's just a calculator job. Yeah? You can literally just stick that in your calculator. There's no variables involved in that thing. Negative 0.65. Cool. There you go. So I agree that out of the three, this one is definitely more work. But let's just break down exactly what we've done, okay? We noticed that we wanted to find x. And the trouble is, x was in the power of two things which had different bases, okay? So first thing we did to make our life easier was basically say, well, look, let's just get rid of the unwanted terms. We don't want the 0. We don't really want this as negative. Let's just bring everything over here on the right-hand side to get 4 to the power of something equals 5 to the power of something. Now, ordinarily, if these were the same bases, if this was like 5, then we could just do the trick which we've done in previous weeks to say that is equal to that. But of course it's not, okay? This is just 4, so it's a different base. So in that case, we just need to take the logarithms of both sides, because the thing which we want is in the power. Okay, the thing which we want is in the power, so therefore I know that if I want to work out what a power is, it usually will result in a logarithm. All right? That's the reason why I took logarithms of both sides. And I said, I don't care what that base is, I'm just going to take log of both sides. Okay? In actual fact, in this case, I mean log of e, but it doesn't matter. On your calculator, it will take it to be log to the base 10. It doesn't matter what that base is, as long as it's consistent. Then I noticed that by law of log, I go, aha, I can get these powers to not be powers anymore. I just use that third law of logs by bringing this power down here and this power out the front of this logarithm. Then I realised, well, okay, let's first of all expand this out to make it a little bit easier to observe and see what's happening here. So when I expand it out, I get this. Bring everything with an x in on one side, all the logarithms, numbers and stuff on the other side, which is what I did to that step there. Then I noticed, I've got an x in both of these terms, factorise that out, get an x there, just be left with this, and just divide by the entirety of that, stick all that in your calculator, you're in business. Is that okay? So it's a little bit more work, just need to be a little bit more kind of fluent with your algebra and keep your wits about you, but it's not that much more difficult, okay?